So in this first video looking at Venn diagrams, we'll be focusing on the actual diagrams itself, where it's used, notation, and also how to shade in a Venn diagram and also read off a Venn diagram that's been shaded. Now, a Venn diagram is used to show the distribution of data amongst groups. How this differs from any other charts or graphs is that a Venn diagram you can also see how many are included in more than one group. So for example, if we look at, if we were to calculate how many people attended both art, maths and English revision classes, then in a bar chart or a vertical line graph, so for example, if I just get difficult pen, so here if I had a bar chart, then again I should be using a ruler, but what chance I'll try and do a bar chart correctly in terms of leaving equal widths. So here you can see, and then what I'll do is I can read off the frequency scale and see how many were in art, how many were in maths and how many were in English. However, the problem is what happens if there is a possibility of people attending both art and maths classes. Now, are they going to be added to the heights of these frequency bars, or are they going to be just allowed to choose one? So that's where it becomes a little bit more complicated. Whereas if we had a Venn diagram, then let's say I just put some random numbers in here, and I'll try and mix it up so that they're all different, so you can see level what it used for. So let's just correct that, and let's go for 7, 8, and 9. So from this Venn diagram, if I just put a little bubble around it, I can see actually how many studied art, how many went to art revision classes, how many went to maths, how many went to English, how many students went to all three, how many people went to both art and maths, how many people went to English and maths, and etc. So if I just get the highlighter, so I know that these 6 people went to both art and maths because they're included in both circles, and a total of, and let's go for pink. So if I add up all of these numbers, that would be how many people went to art revision classes. So that would be 9, 13, 18 students went to art. How many students, I could ask how many students went to just maths and no other revision classes, then that answer there would be 7. So there is a lot of information you can read from a Venn diagram, which why it has its advantages over, let's say, a typical chart or graph that you use in statistics. Now, when it comes to notation and presentation, so a Venn diagram can have more than 2 circles, and they don't all need to be overlapping. In fact, they should only overlap if there is a number greater than 0 going into that particular section. And circles where they do not overlap are what we call independent events or groups. So an example of this is, let's say, if I had maths and art, and let's say obviously this first section represents, so those 3 people, let's say, represent just people who just do maths. 4 would be the number of people that studied both maths and art because they're in both circles, and 7 people are just choosing art. Now, if this number, so if there was no one who studied both maths and art, then really those diagrams, those circles should not be overlapping. And therefore it means that those 2 classes are independent, in which you can only choose one or the other, you can't have both. Now, and that's what we mean by independent events. Now, inside each circle should contain either the frequency of that section or sometimes the probability of selecting someone or something from that selection, which can be written inside. So we've already talked about the numbers inside a Venn diagram representing the frequency, or how many of something you've got or how many people you've got. But at a much higher level, when you're incorporating Venn diagrams in probability, then sometimes it can include the probability, which I'll go through in due course. Now, in any Venn diagram, a box should be drawn around the diagram to represent that this is the entire population, or that there aren't any row groups that have been missed off. So for example, what you don't want is, here we've got maths and English. Now you need to make sure that you do draw a box around your Venn diagram, to the point where you might even lose a mark by not drawing a box. And basically what that box represents is that there are no other external groups in this particular population in terms of this particular situation, because you don't want, let's say, a little group here that's going to, let's call that which lesson do we have, English, like so. Whereas, and likewise, hypothetically, you could have this Venn diagram here where you've got maths and art, and way over here I've got English. So what you don't do is draw a box around your Venn diagram just to imprison those groups, so that there are no other sort of things that you need to be looking into in terms of dealing with this particular situation. Now, a typical Venn diagram with two groups looks just like this. And again, it's important that you read off the key bits of information from this particular diagram. So here, in terms of this number here, that's so 45 people just do art, let's say. So if we imagine that this Venn diagram is how many people like each of these subjects. So 5 people would represent that they like both maths and art, and this number here represents how many like maths. Surprisingly that there's less number than art, but there you go. And this entire circle, which would be 32 plus 5, which equals 37, or basically those the total number that like maths. And likewise, if I got a different color, let's highlight it. So if I highlighted all of this, then that would be, so the total number of art would be 45 plus 5, which is 50. And we've also got a number that lies outside any of the circles, any of the groups, which is this number here, so 7. So 7 don't like or didn't choose maths or art. So it's really important that you understand the components of each of these of a Venn diagram to understand what the numbers actually represent. So if you're wanting the total group, you need to add up all the numbers in the circle. If you're wanting certain parts, then you need to just kind of be aware of what that part actually does represent. So now let's have a look at a Venn diagram that involves probability. Now this works in exactly the same way. However, rather than dealing with frequencies, instead we're dealing with the probability of selecting someone from that group. So for example, if I was asked to work out the probability of maths, then that would be both 0.4 plus 0.2, which would give me 0.6. If I wanted the probability of art, then that would be 0.3 plus 0.2, which equals 0.5. If I wanted the probability of both maths and art, then that would be 0.2. And if I wanted the probability of neither art or maths, then that would be a probability of 0.1. So again, we can use Venn diagrams in more than one different way. So we can use it representing frequencies, or we can represent it using probabilities. Now the key thing to remember is that, and again this is really important fact, so in terms of something to note, that when it comes to probabilities, all individual probabilities should add up to 1. So because obviously we're dealing with the whole entire population. Now because we've got a box around this Venn diagram, it means that every single one of these probabilities, when I add them up, should add up to 1. So for example, a typical question might be is how many people don't like maths? What's the probability of selecting someone who doesn't like maths or art? Then all I need to do is add up the probabilities of maths, art and both, and take it away from 1. So again, it's a very common question that comes up. So if you find that there is something, a probability missing, or even a total that's missing, then all of the numbers inside that box should add up to the total. So whether it's the total frequency or if it's related to probability, should all add up to 1. So let's have a look at some probability notation. Again, this does appear both on the higher and foundation. Again, in maths, we tend to use symbols to represent words to stop us from writing loads, even though, as you can well tell from my presentations, that there is a lot of writing. So in terms of probability notation, so rather than writing probability, we usually write just the letter P, and in brackets is the event. So PA represents the probability of A. Probability with A with a little dash basically means that dash means that it's not that particular event. Now a U, if you see like a U or uniform as we call it, then that represents the word or. And if you see the reverse of that, that represents and. So if you treat like some terms of rag and bone, an abbreviation of the word and, some people in more slang terms or Urban Dictionary times, they just use the letter N. So that's another way of and remembering that the N sort of symbol, because that's what it looks like, represents and obviously then the other is or. And then obviously here we've got A dash and B dash, which basically means probability of not A and not B. Now there are lots of other combinations, even more so when you have more than two groups, so it's really important that you understand the notation rather than trying to simply memorize it. So it's important that, I would say, the most important things is recognizing what probability of A means, what the dash means, what this U symbol means, and what this and symbol means. And once you've mastered that, then it should make sense and should be very easy for you to read something like, for example, if I asked you to read, let's say, this, what does that mean? Well, it means the probability of M or, which is what this means, or not N. And so you should be able to read from this notation and sort of speak out what it actually represents in words. So let's have a look and relate this to a Venn diagram. Now what I'm going to do is I'm just going to highlight each of these sections in different colours. So for probability of A, which I'm just going to highlight in red, that's basically everything in the red, in the circle of, or the oval I should say, of A. Looking at A and B, so that's going to be this middle section here. And let's just do a few arrows so you can see what that represents. And the probability of B, and again let's try and use a more distinctive colour, which is going to be everything in the circle of B. And again, just recognise that the middle section is going to have quite a lot of colours, which is there. And the probability of A and not B is basically going to be everything that's not included in those circles or ovals, whatever you're going to call it. Now I'm going to call it circles, even though clearly they are not. But again, it doesn't really matter as long as they're like hoops. And then that is represented by everything that's not. Now typically in an exam, particularly on the foundation paper, you might get asked to either shade in parts of a Venn diagram, which we'll move on to next, or be able to describe from a diagram with the shaded areas which are the probabilities that it does represent. I vaguely remember one past paper where this was one question where they gave you a diagram very similar to, let's say, something that looks like this. So they had A and B, and they have two circles, and they said, what is the probability that is represented by this diagram? And then what you had to do was just select either probability of A and B, probability of B, and probability of A and not B. And then you just had to select which one it is. So it's really important that you do gauge, regardless of being able to work with probabilities. Now, when it comes to combining events of shading certain areas, so when shading or highlighting parts of a Venn diagram that represent notation, it's recommended that you shade each event separately, also with a different colour, texture or shading technique. Now, one thing I do have to advise you is that in a formal exam, that you should be using either black ink or blue ink. Now, obviously pencil markings are required for diagrams, but any forms of colours, like either coloured pens or coloured pencil crayons, are not necessarily going to come up in the scanning of your paper. So just be aware that, make sure that you are highlighting the main areas in a pen or colour that is going to be required from the exam paper. Now, if you have a or symbol, then the required area is where any shading is. If you have an and symbol, then the required area is where any shading is done the maximum number of times. So for example, if you've got two groups, then the and will be where both of those two shadings are. If you've got three, it's where three areas have been shaded, or three colours or three types of shading that you may have. Now if that makes absolutely no sense to you at all, do not worry, because I will go through what that all means. But I certainly would make a note of those two. So let's put it into practice of what we actually mean. So in terms of this, what I'm going to do is I've got my probability notation, and what I'm going to do is I'm going to show you on the Venn diagram what area is represented by this. Now, if a question had numbers filled into this diagram, all you'd need to do is just simply add up all the numbers that are cocooned in the shading area. So with this, we've only got one event, and this is saying, so let me just write here, we've only got one event, because I've only got one letter. So here I'm looking for the area that is not A. So A is this circle here, which I'm just going to highlight in blue. So that is my A. So not A would be everything outside of that circle. So it's going to be everything that is included in this pink area. And that area represents not A. So then if we move on to our next question, so here we're asked to look at not B. So if I just highlight where B is with a green circle, then not B would be everywhere that's outside that green circle. So if I go for a different color, let's go for blue, and I highlight everything that is outside of that green circle. So if there were any numbers in each of these, how many areas have we got? 2 areas. Then what I would do is I'd simply add them up, and that would represent the area that is represented by not B. Now the next thing we look at is A and not B. Now here we've got 2 events. Oh, let's use a different colour pen, so let's get rid of that. So here what we've got is we have 2 events. Now one event is A. So if I just shade in the area of A in red, so this is what's represented by A. And then if I use a different colour and shade in all the areas that's not B, so not B is everything that is not included in the B circle, which is there. And now because I've got the and symbol, I want the places that's shaded in twice. I want areas which are shaded twice. So in other words, red and green. So in terms of the areas that are both red and green, which I'm just going to use this blue, it's basically this area here. Again, I don't know if I've used an appropriate colour to make it stand out. But basically it's just that area there. And that's all I would include. So when you've got and, it's the places that are shaded in twice. So moving on to the next example. So here we're looking for not A and not B. So again, I'm going to take these areas separately. So not A, I'm going to highlight in green. So that represents not A. And not B, I'm going to do in pink. So B is this area here. And so because obviously it's and, I want the places that's shaded twice. So which places are shaded twice? Well, that's going to be this area here. And that's going to be there. Now another one thing I shall go back and say that this is also, so also can also be known as just B. So it's just B. I don't want anyone who study, let's say, is part of A. I just want exclusive to B. And likewise, if I just go back up, that this section here, or this probability, is also known as, so AKA is just A, is basically what I'm wanting. So I'm just wanting just the proportion of that Venn diagram that is just A. So moving on to the next diagram. So here I'm going to have got not A and not B. So again, I'm going to take these areas separately. So I'm going to do one after the other. So not A, I'm going to highlight in blue. So not A is everything that's outside that circle of A. See, you don't have to be ridiculously neat, but just make sure that you're not going into areas that's not needed. And not B, which I'm going to highlight in orange. So not B is everything that is highlighted outside of that circle of B. Like so. Now because again I've got an and symbol, I want the places that's shaded twice. So looking at my Venn diagram, which areas are shaded twice? Well, again, if I go for a different highlighter, let's go for something a little bit darker. Try and struggle which colours I've not used. Let's go for grey. So the areas that's shaded in, that's twice, is actually going to be this outside area, because they're the only that's the only parts that I've got both orange and blue. And there you go. So this is basically, can also be known as, so AKA neither A or B. So there's different notations in which you can write. So even though I've used the word and in the actual probability notation, but it can also be written another way of asking you what's the probability of not being in either of those two groups, which can be written in that notation you can see on your screen. So let's look at the next one. So this one we've got an or. So again, I'm going to take each section separately. So I'm going to highlight not A in blue. So not A is everything that's outside the blue circle, the blue circle, not blue circle, a circle I should say. And then B, I'm going to highlight in orange. Oh, let's go for a little bit more prominence. Let's go for pink. So B is going to be this section here. Now with or, now because this is an or, I want all shaded areas. So it doesn't matter whether it's got one colour or two colours, I just want them all. If it's coloured in, I want it. Okay, and that's what this represents. So the area which is going to be A, not A or B, which I'll highlight in there, is going to be everything that has been coloured in. So I want this. Now again, remembering that what I'm doing is I'm shading in the areas that I want, not the bits that I don't want, which again is a really important thing when it comes to shading. Is sometimes when you're colouring something in, you're kind of getting rid of it, what you don't want. But in this case, I'm actually shading the bits that I do want. And not doing a very good job of it, but there you go. So in other words, what this can also be known as, so AKA, not just A. Okay, so I don't want people who are in A only, I want everyone else. A and B is fine. I don't want people that are just A. Now moving on to the next one, again I'm going to do this separately. So again, A, I'm going to highlight in green. There you go. And not B, I'll highlight in pink. So not B is everything that is not in the circle of B. Now again, because I've got an or, I want all shaded areas. So in terms of this, I want everything that's got a colour in. Obviously I know white is a colour, but actually it's a shading. But basically this is the area that I am wanting. And hopefully you'll do a better job of colouring it in. So moving on to our last one. So again, looking at this, so this is a probability of not A or not B. So again, highlighting not A in blue. So that's going to be everything that's not included in that circle of A, which is this region here. And then I'll highlight not B in pink. So not B is everything that is not included in that circle of B. Like so. So you can see I've got areas that is just blue, just pink, and both. And again, because I'm wanting all, I'm wanting all shaded areas. So in other words, if I highlight it, the bits that I want in grey, it's basically everything apart from that middle section. And like I said, hopefully if you're going to be shading this in, you're going to do a much neater job of what I'm doing. And there we go. And that is it. So I will do another video where we're answering questions based on Venn diagrams, and where you can use everything that you've kind of learnt in this particular video to apply it to actual probability and Venn diagram questions.